This is the prototype for the Keypad voltmeter, which is a project based on Kirchhoff's voltage law, or KVL. KVL states that the algebraic sum of all voltage differences around any closed loop is 0. This prototype contains 4 momentary push buttons, 2 1K ohm fixed resistors, a 4.7K ohm fixed resistor, hookup wires, and a 9-volt power supply. The path of the current through button 1 would come from the positive rail, through button 1, down through a 1K ohm fixed resistor. Button 2 would go down through button 2, and then through both 1K ohm fixed resistors. Button 3 would come down through here, through button 2, through a 4.7K ohm fixed resistor, over through button 3, and through the 1K ohm fixed resistor. For button 4, come straight down the side, through the 4.7K ohm fixed resistor, and through button 4, and through both 1K ohm fixed resistors. The point of the project is to measure the voltage drop through this 1K ohm fixed resistor, which I'll show in the formulas. In this equation, we are calculating the voltage drop around the 1K resistor. So the equation would be the resistance from that specific resistor over the total resistance in that circuit multiplied by the voltage from the supply. So in key 1, we have only that 1K resistor, meaning 1 over 1 times 9 is 9, meaning that resistor takes up all 9 volts provided by the supply. For key 2, there's 2 1K resistors, meaning 1 over 2 times 9, each of them takes up 4.5. And then in key 3 and 4, we have 1, which is the resistor that we're calculating for, over the total, which is 5.7 times 9 equals 1.58 volts. In key 4, we have all 3 resistors in the circuit, meaning 1 over 6.7 times 9 is 1.34, meaning that 1K resistor that we're calculating for takes up each of those values. Here we have the final Keypad voltmeter device. Soldered to the top of the PCB, we have the 4 momentary push buttons, 3 fixed resistors, and the DMM terminal block. Soldered to the bottom of the PCB, we have the 3-position terminal block and the power terminal block. The 3-position block goes to the display, and the power block goes to the power jack behind the display here. When we plug in the voltmeter, it'll be zeros because none of the buttons are being pressed, meaning no current is going through any circuits. When key 1 is pressed, it should be 9 volts. Key 2, 4.5. Key 3, 1.5, 1.58. And key 4 should be 1.34.